Hi everyone, welcome back. Today we're going to be looking at standard 6.ee.a.3, apply the properties of operations to generate equivalent expressions, and standard 6.ee.a.4, identify when two expressions are equivalent. Some important key terms: equivalent, when two things have the same value. We use distributive property and combining like terms to simplify expressions. These simplified expressions give us equivalent expressions. For example, 6 times the sum of x plus 2. Here we would need to use distributive property to simplify. And when simplified, we have 6x plus 12. So although these two expressions look differently, they are equivalent. 3x plus 4x, here we have like terms. So if I combine them by adding my coefficients, I get 7x. So 3x plus 4 and 7x are equivalent. Now let's use x equals 3 to help us prove that these two scenarios are indeed equivalent. So if I have 6 times the sum of x plus 2, and I have 6x plus 12, and I substitute x for 3, these two should be equal. So let's go ahead and do that. So here we know order of operations. We complete what's in our parentheses first. So 3 plus 2 is 5 times 6 is 30. And then here we have 6 times 3 is 18 plus 12 is also 30. So both of these expressions, although they look different, are equivalent. Let's try the next one. So 3x plus 4x and 7x. So we're going to go ahead and use the same x's equal to 3. So we have 3 times 3 plus 4 times 3. And then we have 7 times 3. 3 times 3 is 9 plus 4 times 3 is 12, which is equal to 21. 7 times 3 is 21. So here we find that although they look different when evaluated, they are indeed equivalent. So when we look at the expression 3x plus 6 and we think about, what are some other expressions that could be equal to this? You want to do reverse distributive property, reverse combining like terms to write some similar expressions. So if I did reverse distributive property, I can say, okay, I'm going to pull a 3 out, and I could rewrite that as x plus 2. Okay. Now let's actually go ahead and see if it works. 3 times x is 3x. 3 times 2 is 6. So that definitely works. I know there's someone out there who's going to say, oh, what about 3 times x plus 6? Now, this would not be a like term to this, and this is why. If we were to go ahead and simplify, the 3 times x will give us 3x, but 3 times 6 is 18, and that is not equal to the other. Okay, so let's go ahead and erase that, because that does not work. Now, what about if I decided to split up my 3x into x, 2x plus x, and then I carry my plus 6? That is indeed equivalent. What about if I did 3x plus 3 plus 3? Yep, that's also equivalent. What about if I did 3x plus 4 plus 2? Yep, if I simplify, combine my like terms, it definitely works. What about 2x plus 1x plus 5 plus 1? Yep, that's also equivalent. So all of these, although they look different, when simplified would take us back to 3x plus 6. All right, let's go ahead and take a look at these other examples. So here I have b plus b plus b plus b. We know that the invisible coefficient in front of these b's would be, 1. So this is 1b plus 1b plus 1b plus 1b. And we can combine, so that would be 2b plus 2b for a final answer of 4b. So both of these expressions are equivalent to b plus b plus b, but when we simplify, we want to simplify it all the way. So 4b would be our final answer. Now, what about if I had b times b times b? What would that simplify to? I hear someone saying 3b. Now, that would not be correct. And the reason is here when we add, the number, the coefficient is what will change. But what happens when we multiply something by itself? Yep, exponents. So if you said b times b times b is going to give you an exponent, then that is correct. That would be b to the third power. So the base is being multiplied by itself 3 times. Okay, now let's go ahead and take a look at the next example. So what can I do to this example here to simplify? If you said distributive property, then you're absolutely correct. So let's go ahead and rewrite it where we have a little bit more space. What am I distributing? I'm distributing the 5 through to everything in the parentheses, not just to the x, but also to the 1. So that would give me 5x plus 5 plus 1. That is an equivalent expression, but I want to simplify it further. I see like terms in my positive 5 and my positive 1. So 5x plus 6 would be my final answer. Okay. If you want to see one more of those examples, let's go ahead and try it. What about 3 times x plus 1 plus 2? It's the same process. I'm distributing through to everything in the parentheses. You would not distribute the 3 to the 2 over here because it is outside of the parentheses. 3 times x is 3x. 3 times 1 is 3, and then I bring down my 2. Now I'm going to combine my like terms, which gives me 3x plus 5. Okay. Now let's take a look at the next example. So here we see combining like terms. So I'm going to use my shapes to identify my like terms. So I have 3k and positive 1k. Then I have a positive 4 and a positive 8. So 3k plus 1k is a positive 4k. And I can bring down my plus 4 plus 8. That is an equivalent expression, but I can simplify it further for 4k plus 12. Now, if it's asking you just to solve it, you want to bring it all the way down here. You want to simplify it all the way. However, you have to know that equivalent expressions can look different. So 3k plus 4 plus k plus 8 is equivalent to 4k plus 4 plus 8, which is equivalent to 4k plus 12. Multiple choice questions will have a variation of answers. You would need to be able to identify which one is equivalent, even if it's not completely simplified. All right, here we have 2 more examples that involve combining like terms. So I'm going to go ahead and do the same thing I did in my previous example, which is to use my shapes to identify my like terms. Okay, so 9c plus 2c is 11c, and then I'm going to bring down the rest of my like terms. And then 12d minus 4d are like terms, so that would give me a positive 8d. Okay, different signs subtract, keep the sign of the larger number. So here the simplified answer is 11c plus 8d. Okay, let's go ahead and do the same thing here. So we're combining those like terms. Remember to include the sign with your answer. Okay, and the negative 2 is by itself. So 6w squared plus 8w squared is 14w squared, and I'm going to rewrite everything else. Okay, then I have my 11w and my 15w, so I'm going to combine those two for 26w. And then my 2 is left over, so I'll bring that down. So this here is your simplified answer. All right. Thank you for watching and have a great day.